lesson, the title of the lesson is called Distributive Property again, because what we're going to do is we're going to revisit the distributive property, which we learned about earlier this unit. But this time, you're going to notice something a little bit different that we didn't have when we learned it first. So let's read what the little bear is saying. He's saying, for each term, multiply the coefficients first, and then the variables using power laws, collect like terms, and simplify. So we do have to remember our power laws, which means when you have two bases that are the same and you're multiplying them, you're going to add the exponents together. So we're doing 6 examples together. We're going to start off with really basic ones, and then we are going to move on with more difficult ones. But just looking through the sheet, what do you guys notice is a little bit different on this page than it was in the distributive that we did earlier? Anyone see a difference? Peyton? Yeah, this time we actually have a term in the front of the bracket that has a variable. Before, it was very straightforward. It's just a number like 2 or -3 or -1. But now it's going to be things like 2x, 5a squared, etc. Okay, so we'll walk through how to do that. If you take a look at the first example, we are first going to start by multiplying x times x, and then we're going to multiply x times +3. So using power laws, x times x, it's kind of like saying x1 times x1. The bases are the same. You add the exponents, and so you're going to get x squared. And then x times +3, there are no like terms. You can't use power laws or anything like that. You're just going to glue them together, and it's just going to be +3x. And that's your final answer. So it's not super tricky or anything like that. You just have to be mindful that now you're using your power laws again. Questions about that? Yes. In a bit. Let's look at question number 2. For question number 2, we're going to multiply 2x times x squared, then 2x times -2x, then 2x times +5. Okay. I'm actually just going to show you some of the work on the side in case you prefer that. So the first term we're multiplying is 2x to the power of 1 times x squared. This is like what we did before when we were multiplying monomials. You first multiply the coefficients. 2 times 1 is just 2. What's x times x squared? X to the power of 3. Good. So that first term is going to be 2x to the power of 3. Do you need to show any work on the side? Nope, not at all. I'm just doing that so you can visually see what's happening. I'll do it maybe for the first 3 questions, and then the rest we'll try to do mental math. The next 2 terms are 2x times -2x. And keep in mind that if there's no exponent written, it's going to be a 1 and a 1. So what's 2 times -2? What's x1 times x1? X squared. And so when you multiply 2x times -2x, you're going to get -4x squared. Yep. Yep. Nope, because for the first one, it's just 1x times +3. You're not multiplying the x with any other x, so it just stays x to the power of 1. Okay, and the last term here is 2x to the power of 1 times +5. Can't really use power laws. There are no like terms, so we're just going to multiply 2 times 5 and attach the x. So it's going to be +10x. Does this make sense? Any questions? Okay. Let's try the next one without breaking it down. We'll try to do this one just ourselves. So again, what are we multiplying? We're multiplying 2a squared times a to the power of 4, then 2a squared times 2a to the power of 3, then 2a squared times -3a. Okay, 2a squared times a to the power of 4. 2 times 1 is 2. What's a squared times a to the power of 4? A to the power of 6. And we got that because we just added the exponents together because they are power laws. We use power laws. The next one, 2a squared times 2 to the power of 2 eighth to the power of 3. So what's 2 times positive 2? Positive 4. We multiply the big numbers first, the coefficients, then we deal with our a's. A squared times a to the power of 3, a to the power of 5. And then the last one is 2a squared times negative 3a. What's 2 times negative 3? Good job. And what's a squared times a to the power of 1? A to the power of 3. Thank you. All right. Now we're getting on to the harder questions. You're going to notice in question number 4, we have 2 separate brackets. So we're going to multiply the 5x to everything in the first bracket, and we're going to multiply the negative 2 to everything in the second bracket. All right, so let's try this. Can I get a volunteer to help me with the first bracket? Zishan, go ahead. Good. Can I get a volunteer to help me with the second bracket? Banujan, go ahead. Excellent. I'm going to go ahead now, and I don't have to collect like terms. Everything is sort of already in the order. So all I'm going to do is I'm going to add the 2 middle terms together, which have the x's. Remember, a like term is something that has the same letter and the same exponent. And in that case, don't get confused with multiplying. If you have a plus or a minus sign, you keep the variables the same. So when I do negative 30x minus 6x, I'm not going to make it like 180x squared. I'm not multiplying them. I'm just adding them. So all I can do is add the numbers together. In this case, it'll be negative 36. And then the variable stays as is. Can I do anything else with this question? Can I collect any other like terms or do anything else? Nope, that's the final answer. That's what we're left with. Okay. The next question, a volunteer to simplify the entire first line. Sharia, go ahead. Yep. Minus 12. So there's something else you're missing with the minus 12, or maybe you said it and I didn't hear you. Yep. Yep. Thank you. You want to just keep going? Yep, you're perfect. Now, what are the like terms that I can add? Yep, so it's going to be 4x cubed minus 14x squared minus 6x. And can I add or subtract anything else? No, these are all unlike terms. That's all you can do. Perfect. Last example. A volunteer for the last example. Priyanka, go ahead. Yep. Good, keep going. Oh, so before you do that, I'm just going to collect like terms. So 6x squared minus 2x squared minus 8x plus 6x plus 10. Okay, go ahead. Yep. Plus 10. Good. So not too bad, right? Kind of more of the same stuff. To get more practice on this, you guys, there are textbook questions at the bottom, page 322, numbers 1 to 46, even in 47A. Just stop this recording here and I'll tell you what you